Okay, so the topic of this video is going to be the chain rule. Now, the chain rule in the course, as I hope you've observed it in the notes, is written out dy over dx is equal to an expression here, dy over du times du over dx. Now, if this were simple algebra and not calculus, you could cancel the du's and you would have the same expression on the left and the right. But the u itself may be a little confusing. We see that algebraically it's the same, but what is it conceptually? What's the u? Now, when you look at a chain rule problem, it might look something like this. Y equals x plus 2 squared. When you think, what is the u, I want you to think the stuff in the parentheses. U equals stuff in parentheses. Now, there's your highly mathematical definition for you to some power. But this is the practical working definition. So how does this work? That formula may not be intuitive to apply. So if I were to give you this problem to derivate, what a lot of my students do is this. They would FOIL it out. They'd say x squared plus 4x plus 4, and then they take the derivative in the standard way. You get 2x plus 4. But what happens if you don't have something that's easy to multiply? What if that squared there was a much uglier exponent? What if it was the 15th power? Now, some of you may want to break out your Pascal's triangle and multiply that one out. That'd be a good exercise, but it would take all day. I'm a little lazier than that. So I'm going to apply the formula to this problem. Now, first off, I said we need to pick the u. Now, the u is the stuff in the parentheses. Couldn't be any easier than that, right? U equals x plus 2. So now we just need the parts that are listed above. We need a dy du, and we need a du dx. So if we were to put this y equals equation in the u form, what we have is that it equals u to the 15th. Alrighty, so let's get our dy du. dy du is equal to 15 times u to the 14th power. 14th power. There we go. And if you want to plug your u back in so that you have this form in x, then that's equal to 15 times x plus 2 to the 14th power. Yeah. There we go. Nice ugly 14 there. Okay. So now all we need is a du dx. Du dx is equal to 1. The derivative of x plus 2 with respect to x is simply the coefficient of the x, 1. Now when you multiply this expression by this expression, you have your answer. The total answer, dy dx, is just equal to 1 times 15 times x plus 2 to the 14th power. And that's how you work a chain rule problem. Now, for some of these, it may not be convenient to always have to write out the u. You don't have to write down something this formal every time. What you may write looks something more like this. Let's erase here. Typically, what a student or myself would do is just first take the derivative of the outside. 15 times x plus 2 to the 14th, and then multiply by the derivative of the inside, times, in this case, simply 1. Now, you may hear that as a shortcut to the chain rule a lot. The derivative of the outside times the derivative of the inside. These are both equivalent forms. This way takes up less ink. So, okay, maybe the inside on this one was too simple. Maybe x plus 2 doesn't really show you everything that this can do. What happens if you have something a little uglier? What happens if we have y equals x cubed plus 5x plus 7 to the 9th power? Now, as you've seen from the last example, it doesn't really matter how high that power gets. It could be to the 150,000th power. Very unlikely, but even if it is something enormous, you're going to work the problem exactly the same way. Now, I'm going to do this with the outside-inside trick I just taught you. So, y prime here, or dy dx, whichever one you want to call it, is equal to the derivative of the outside, 9 5x plus 7, times the derivative of the inside. Absolutely no different. That 3 there, squared, plus 5. Get that 8 rounded out a little bit. So there you have it. Now notice there is no exponent right here. This spot right here is just 1 power. Nothing unusual there. It doesn't matter if your initial exponent was 3 billion. There is still only a 1 right there. Also notice that I have not altered the original expression right here. It's exactly the same as it was above. So you can see here that the chain rule is actually quite simple to employ, even if it's not intuitive at first. Okay, stay tuned for the next video.